Hi, everyone. Wanted to do a quick video on the relationship between precision and recall. I saw in a lot of the updates that some of you were giving precision and recall as trade-offs or um, yeah. So I wanted to kind of clarify a couple things. One thing is just to kind of realize and remember that for a given value of k, right, 1%, 2%, 3%, or 100, 200, 300, there is a one-to-one relationship between precision and recall. So if you do model selection to pick the best model at precision at 5%, it will be the same model if you did model selection for recall at 5%, if you maximize one or the other, because there's this one-to-one relationship. There are a few ways of thinking about it. One, at a very high level, is, let me share my iPad, right? So one at, yeah, is, remember this graph that we talked about, this is K and this is precision, and that's recall. And so if precision is coming down, and let's say, and recall is sort of going up at any point K, right, there is a one-to-one relationship, right? For any value of precision, and there's a one-to-one correspondence to a value of recall. So that's kind of one just high-level thing to keep in mind. Is once you pick your K, you can't trade off precision and recall. Once you pick a K, you get a precision and you get a recall. And a model that's doing higher at precision than other models will also do, by definition, higher at recall. A different way of thinking about it is, just of, precision is two positives, right, divided by all the predicted positives. So that would be true positives and any of the false positives, right? And this is also your K, basically. And recall is all the positives you predicted divided by all the positives that were there. So your true positives, and then the ones you missed, which are the false negatives. And this is also sort of total positives in the data, right? So now if you sort of look at the relationship, right, it's basically your recall becomes precision times true positive plus false positive divided by true positive plus false negative, right? So once you have a precision, the data has already fixed all these other things, right? So again, this is your K and this is your sum of your positives. And so that's the relationship between, once you fix a K, your data has a fixed, the test set has a fixed set of number of positives. You picked a K, then whatever your precision is, recall is precision times that K divided by that. So there is this one-to-one relationship, right? And if you work through the actual math, let's say you tell me that my K is 10%. I'm going to intervene on the top 10% of the people. And my base rate for the positive class is, let's say, 20%, right? So now if you tell me, hey, my model at the top 10% has precision of 60%, K is 60%, what does that mean? Well, that means that when I look at the top 10%, 60% of them are ones, right? So that means that I get total of 6% ones in there. My total ones in the data are 20%, right? So what's my recall at the 10%? It's 6% divided by 20%, right? So that's 30%. So once I know my K and my base rate, if you tell me a model that has 60% precision, by definition, its recall has to be 30%. because it's taken 6% of all the positives of the 20% that existed. And so now it still has 70% left over. So hopefully that was helpful and clarifies this relationship between precision and recall. So